Hello students, so today we are going to discuss the next topics of the chapter motion of class 9, that is speed, velocity, acceleration, okay, the graphical methods of representation. So first we will see what is speed and what is velocity. So we know that the speed is rate of change of distance. This is speed, and the rate of change of displacement is velocity. Clear? Suppose you are moving through a path length, a definite path length, okay? So rate of change of distance is called speed and rate of change of displacement is the velocity. So speed is what? It is a scalar quantity. Scalar quantity, and velocity is vector quantity. So speed has no direction, only magnitude, but velocity has magnitude as well as direction. Clear? Now speed, if an object is moving, in that case speed cannot be zero. It cannot be zero. If an object is at rest, then speed can be zero. Okay, speed is zero if the object is stationary. But if the object is moving, in that case speed cannot be zero, but velocity can be zero. Okay, it can be zero. Speed can't be negative, but velocity can be negative. So these are the differences in between speed and velocity. Now what is the mathematical representation of speed? So speed is, it is denoted by phi. So the formula is distance covered by time taken. This is the definition of speed. So distance covered we termed as s, time taken it is t. So v is equal s by t is the definition of speed, a mathematical representation of speed. Same case in case of velocity also. Velocity, it is also denoted by v. Here total displacement by total time. Clear? So total distance s, time t, v is s by t. So the formula of velocity and speed both are same. Distance by time, here displacement by time. Clear? So speed is v is equal s by t, velocity is also v equal s by t. What are the SI units? SI unit is, for distance it is meter, for time it is second. So meter by second is the SI unit for speed, and velocity also same. It is SI unit of velocity is meter by second. Clear? So these are the definition and mathematical formation, also the differences between speed and velocity. Now we will see the average speed or average velocity. What is average speed? Average speed means, suppose you are moving from position A to position B. Suppose the total distance is 60 km. Now someone is asked you that in how many speeds, how much speed you are traveling. So you will say that approximately this speed. That means that is the average speed. Okay, suppose you are moving from A to B, total distance is 60 km. Suppose you have completed 60 km in 2 hours. So for average speed, that is the average speed. Average speed you have to calculate by total distance traveled by total time taken. This is the average speed. So v average you can write total distance s by total distance t. Formula is same, but the concept is different. Okay, you are moving from A to B. What is your average speed? Average speed is how many distance you have traveled divided by how many time you have taken. If you divide that, you will get the average speed. Almost it is same, but in case of average velocity, the formula is something different. Suppose you are moving from A to B. Here your initial velocity is u. Suppose your initial velocity is suppose u. Final velocity suppose v at the point B. Okay, now your average velocity will be initial velocity plus final velocity by 2. It is the arithmetic mean of the average initial velocity and final velocity. Average velocity will be the arithmetic mean of the initial velocity and the final velocity. Clear? So these are the topic of speed and velocity. See, these are the graphs between the speed and velocity. If you plot the graph distance versus time, it gives speed. If you plot the graph displacement versus time, it gives velocity. Okay, so this graph 1, it gives you the uniform velocity or uniform speed. In case of this, uniform speed. In case of this, uniform velocity. These two graphs are the non-uniform velocities. That means in same time interval, different displacements are changing or different distances are changing. Okay, here also these are the non-uniform speeds. Here the time is changing, but distance remains same. Distance remains same. It means that you are at rest. Okay, it means that you are at rest after some time. Okay, this is the type of graphs, that uniform velocity, non-uniform velocity, and zero velocity. Okay, now next topic we will discuss about the acceleration. So what is acceleration? Acceleration is actually, it is the change of velocities. Acceleration is also a factor quantity. It is factor quantity. Acceleration is the factor quantity, and acceleration means change of velocities. So what is it means? Rate of change of velocities, velocity is termed as acceleration. It is termed as small a, denoted by small a. Suppose from A to B, you are moving. At this point A, speed is u. At this point B, speed is phi. Suppose you require time t to move from A to B. Clear? So acceleration A will be the final velocity minus initial velocity divided by time. This will give you the definition of acceleration. Final velocity minus initial velocity divided by t will gives you the definition of acceleration. Clear? Now, what is the SI unit of acceleration? Suppose your initial point. This is your initial point and you are at rest. In that case, u will be 0. Okay, if you put u will be 0, then phi minus 0 by t, a is equal phi by t. So what is the SI unit? SI unit of acceleration. So what is the unit of velocity? Unit of velocity is meter per second square. What is the unit of time? Unit of time will be second. So your unit will be, unit of velocity is meter per second, not second square. So your unit will be meter by second square. So SI unit of acceleration will be meter per second square. This is the SI unit. Now, since acceleration is a factor quantity, so it may be positive or may be negative in some cases. Suppose you are starting your journey with a bike or a car. So your speed is changing, velocity is changing. In that case, your velocity is increasing. In that case, your acceleration is increasing. That is, your car or your vehicle is accelerated. Okay, suppose a bus or a car wants to stop. So suddenly it cannot it cannot push the brake. Okay, so gradually it will push the brake. That means suppose the object press the brakes here, then it will stops here. In this time duration, the velocity will be decreasing. This decreasing acceleration, if the velocity is decreasing, that means acceleration is opposite. So it is called negative acceleration. Negative acceleration or called retardation. Retardation or negative acceleration. Clear? So now we will discuss about some graphical topics on acceleration. So this is a graph between time and velocity. So means these 7 graphs will give you the acceleration, different types of acceleration. Okay, now see the number one is what? Time is changing, the velocity remains constant. Time is changing, the velocity remains constant. In that case, this graph 1 is called zero acceleration. Okay, if velocity is not changing, velocity is constant, it means that zero acceleration, or you can write it is constant velocity. Now 2 number is that the graph is uniform. So it is accelerating, na? It is going upwards. So it is accelerating, but it is not started from 0. That means initially is not 0. Already some velocity is there. So after that it is changing. So that graph 2 is called uniform acceleration with non-zero velocity. Velocity non-zero, not velocity, it is initial velocity. Initial velocity is not 0. So the graph 3 is the non-uniform acceleration. So it is non-uniform. It is decreasing now. After some time it is decreasing. So non-uniform negative acceleration. It is decreasing. The 4 is uniform acceleration. So it is starting from 0. Initial velocity is 0. The graph 5 is, it is also non-uniform. It is positive acceleration, non-uniform acceleration. The number 6 is, it is infinite acceleration. Like a car fails its brakes. Okay, so if the car fails its brakes, then after some time it will collapse to an object. So in that case it cannot reduce its speed. So that is called infinite acceleration. Okay, this type of acceleration is infinite acceleration. Then number 7 will be negative acceleration, negative uniform acceleration, or you can say retardation. It is retardation, or you can also mention it is uniform. It is negative acceleration, but it is uniform. So this is the graph between time and velocity, graphs of acceleration. These graphs, 7 graphs will give you the different kinds of acceleration. The graph 1, it is the constant velocity or zero acceleration. Graph 2, it is the uniform acceleration, but initial velocity is not 0. It is starting from somewhere. Then this graph 4 will be uniform acceleration. Graph 3 and 5 non-uniform acceleration. 6 infinite acceleration. 7 uniform retardation. Clear? Suppose in this graph an object, this is our time axis, and this is velocity axis. So this graph will give you the acceleration. So in this graph an object is moving from A to B. So obviously at A initial velocity is not 0. Suppose at A the initial velocity is u. Clear? So initial velocity is u. This distance you can take as u. This distance you can take as u. Clear? And at this point, A to B, at this point the final velocity is phi. At this point the final velocity is phi. So object is moving from A to B by changing its velocity from u to phi. Clear? So the whole distance is termed as phi. Clear? Now say this is the time taken from O to C by the object, that is t. Clear? This is the time taken. This is initial velocity, this is final velocity at B, this is the time taken. This axis also gives you the time taken, required time taken. And from A to B, the slope, this is called slope. From A to B, this slope will give you the amount of acceleration. Since it is uniform acceleration, this slope will give you the amount of acceleration AB. This is acceleration. Clear? Now, what is distance? How can we get the distance from this graph? Actually, the distance is distance or displacement. Distance or displacement is the area covered by the velocity time graph. Means the whole area from O, this area will give you the displacement or distance, that is area of, say the shape of this is like O A B C. This will be a trapezium, so area of trapezium OABC. This will give you the distance or displacement for the object. Okay, the area covered between the acceleration and this axis is called the distance. This area will give you the amount of distance or amount of displacement. Clear? Now, from this formula, you can find the three equations of motion. So, I will give you the equations of motion. These are the three equations of motion. First one is phi is equal u plus at. Second one is s is equal ut plus half of at square. And third one is twice as is equal v square minus u square. These are the three equations of motion by which you can numerically find out the distance, time, or different uniform initial velocity, final velocity, time, distance, and acceleration. Clear? So you can also prove this formula by this graph. See the first proof. Say the first proof is you have to find out the first formula is phi is equal u plus at. So what is the acceleration? Acceleration is the from A to B. From A to B, it is the acceleration. So we know that you can also write acceleration A is equal phi minus u by t. So how it comes? Basically, acceleration, this axis is acceleration, na? AB is the slope. AB is the slope. You will get in class 10. How can you find the length of the slope? Length of the slope will be, this is the right angle triangle ABC. From this right angle triangle, not C, it is D. Right angle triangle, this is hypotenuse, this is perpendicular, this is base, you can take. So the slope AB, this is the AB slope, and it gives the acceleration. Slope will be gives by perpendicular divided by base. Means perpendicular is BD and base is AD. So what is BD? This distance is BD. The BC is phi. So you can find out also. BD is equal to, the total distance is BC minus this DC. What is BC? BC is phi and DC is u. So BD will be phi minus u. Instead of BD, we can write phi minus u. AD, this is AD. AD means time t. So phi minus u by t is the acceleration. So multiply it. Phi minus u is equal a into t. So V is equal U plus AT. So this is the proof of the first formula. So like this, from this figure you can also prove the other formulas. Okay, in the next class I will give you the other proofs of the formula, the second equation and the third equation, and we will do some numerical values also. So thank you.